Okay, so we're ready to go now. I've put quite a lot of new content on the website today. So there's two new cards here. Now, the way this is going to work is if we just click behind this card, I've actually pre-recorded. It's not a full lecture, it's about 40 minutes, I think. And what this section covers is the kind of methodology or process that you go through when you're designing a React app. We haven't looked at it at all so far. I've mentioned it kind of in passing, all right. So can I just check now that people are hearing me okay?
Yeah, we can hear you fine.
Great. I've mentioned in passing, you know, that that there is a process or an approach towards coming up with a component hierarchy for a React app, but I've never actually delved into it in any detail with you. Well, this set of slides and this recording explains the methodology or the process to you. So I'm requiring you really to go away and look at that yourself. It's theoretical, obviously. I'm using the process to a degree in the labs. The first two labs very much follow the process that's being outlined here. It's actually a process that was created by the React team themselves. So you should probably look at that maybe in the next as soon as possible, really. So I'll leave that to you. And then today, what I want to look at is what's going on behind this card here. Now, I'm going to be giving the first lecture when we come back after the reading week. That's the Monday lecture. And then essentially, I'm going to be handing over to Frank Walsh. He's going to start covering the backend stuff, the web API stuff. So in other words, this is all of the React stuff now. Once I've covered this set of slides here, I've covered all of the React that we need anyway in order to do the assignments. Obviously, there's lots of other stuff, aspects of it that we haven't got around to, but maybe you've been reading around it and you'll be able to bring that into your assignment. What I'll also need to talk to you about is the assignment itself, and I'll do that on the Monday after the reading week break. So this is the last lab in the series of labs to do the movies app. So once you've got this completed, which you probably will do maybe over the reading week, then I'll provide a link on Moodle where you submit stuff, and we'll address that maybe when we come back. But you will be submitting it pretty shortly after we come back from the reading week. So it'll be that week, really, the week after we come back. Right, so this is the stuff that I want to cover today. I won't cover all of it. I don't expect to, and that's fine. I'll just pause for a second in case there are any questions in terms of what I've been outlining there. No. So I'm saying this is the remaining agenda, as in this is all I've left to cover with you from a React point of view. Not a little bit on patterns. There's a major flaw in the movies app that we're rolling out in the labs, and I'll address that when I look at this section here on data fetching. And also, I won't cover today, but there's one other sample in the routing samples that I need to look at, which deals with declaring certain routes as being private or protected. In other words, the user needs to authenticate with the app before they can access those routes, which would be a standard kind of feature for any React app. Certain aspects of the app would be publicly accessible, others might require authentication. So how do we go about that in the case of React? Now, there is this other feature in React called context, React contexts, and really what they are is an implementation of another design pattern called the provider pattern. I haven't mentioned it at all so far. The provider pattern is not specific to web apps, as are many of the patterns that I looked at so far. The same is true of the provider pattern, but it has a particular use case in relation to web apps in general, and consequently in relation to React apps. When do we need to use this pattern is the first question, and the typical use case for it is if you've got some global data that you want to share across multiple components in your app. The kind of question arises, where do you put that data? You could put it into the component at the very top of the hierarchy. The problem with that, though, is it's going to have to pass it via props down to whatever subordinates need to access it. So the general use case anyway is you've got some global data that you want to share across multiple components. That data will be managed by one component, okay, but how it makes it available to those that need it is where this provider pattern comes in and where React contexts come in. That's the major use case. A kind of consequence of this global data requirement is there's something we want to avoid called prop drilling. Prop drilling is a term that I'll just define for you, or I'll explain to you now in a second, but the 1 and 2 are kind of interrelated. What prop drilling is, just if we just take it in isolation, if we, Maria, I think we've got this, apologies now for the image, I grabbed this somewhere off the internet and I don't really like these emojis sticking in the middle of it, but anyway, let's supposing we've got this component at the top of the hierarchy and it's a stateful component, but there are other components, in particular, this one here and this one here and this one over here. Those 3 components need to have access to the values of particular aspects of the state, right? So how do they get those values? Well, they're going to need to be passed down as props. So this component would pass props down to this one. It would pass it all the way down. So the props have to be passed through various intermediary components. Those intermediary components don't need to know about the data, but still they have to accept the props from their parent and pass them on to their child. So they're really only kind of transporters, if you like, these intermediate components. Eventually it will arrive at the component that needs it and presumably displays it or maybe uses it for a computation. So this idea of passing props down through a hierarchy in order to get it to the eventual destination, that is referred to as prop drilling. And it's something we don't like to have in our apps. So that's what prop drilling is, and it's kind of interrelated to global data. It's global data in the sense that the data that's being managed, stateful data that's being managed by this component here, there are other components that need to know about it. Hence, it's kind of global. We refer to it as global data.
Sorry, dear.
Yep.
Should you make, say you're making network calls, should you make that from the app.js, from the original parent component?
It probably would happen inside this component, yeah. So you'd have your use state and use effect hook code going on here. That doesn't change. The problem is that the data is not just required by this one, and maybe not just by these 2. It's actually required by other ones further on down the hierarchy. So we have no other way of, that we know of now anyway, we've no other way of getting it down to those lower level components other than by prop drilling. Okay, so yeah. So how do we avoid prop drilling, or how do we make global data available to lots of other components in the hierarchy? And the answer is we implement the provider pattern. So how does that actually work in a React context? So there's a couple of parts to it. First of all, you've got to declare a component that manages the global data. We refer to that as the provider component. So that would be the one at the top of our hierarchy there in the previous slide. So that's fine. We know how to do that using our use date and use effect hooks. There's nothing new there. Step 2, it says to create a context construct. We don't know what that is. We'll have to see what that is in a second. But essentially what this context construct will be is it will be a wrapper for the global data. But anyway, step 2 is to create this construct, and React gives us a way of doing that. And we need to associate or link this context construct with our provider component. Step 3 is to place the shared or global data inside the context. So the context seems to be kind of a container or a wrapper for this global data. And step 4 is somehow enable consumer components. Those would be the ones that need to have access to the global data, the ones at the lower down in my hierarchy. Enable those consumer components somehow to access the context. So that sounds fairly simple enough. So the new concept here is this concept of a context. It's kind of the glue, as I'm saying there, for the provider pattern. It's a very React specific construct, and it's almost specifically for this use case and for this provider pattern implementation. And as I've kind of already alluded to, what it is it wraps the data that's to be shared across the component hierarchy. The provider component is responsible for managing the context. So it's responsible for deciding what goes into the context. And the consumers then, the consumer components, they need to be able to access the context. And lo and behold, there's a specific hook that will allow us to do that. Now, to be quite honest, the actual implementation, so this is how, without giving you the detail of showing you the code, I'll show you excerpts from the code in a second. And I would argue that this is easy enough to understand, you know, but when we look at the code, it's a little bit clumsy, but we have to live with it. So first of all, anyway, here are the different parts of the implementation. Oh, sorry, before I do that, here's my visualization of it. So this is Maria, the orange box is Maria, my context now. And inside here is this global data. By the way, we could have functions in here as well. You know, if there were functions that we wanted to make available to, you know, this component down here, maybe the function might relate to the ability to tell this component up here, you've got to change your state. So there could be behavior in here as well as data. But as I'm trying to visualize it now, we no longer have prop drilling going on now. Somehow these components can access the context area, whether that be just read the data or potentially invoke the functions that are stored inside here. Right, so this is the different parts of the implementation, and there are, I think, three parts to it, and we will use this in the lab accompanying this set of slides. So you'll use it not in this week's lab, but in kind of next week's lab, if you like. So that's where I don't have a sample app illustrating it. I decided I'd let you actually experience it in the lab itself. So step 1 anyway, to declare your provider component. There's nothing unusual in this. This is the provider component. It's an ordinary component. It probably will have use state and use effect code in there. So there's nothing unusual there. Now, this line here is critical. This is how we create an empty context. So there's just a special function, or method, I suppose, associated with the global React object. And that returns a context construct for us. We don't need to know what the structure of it is or what this thing is. It's my empty orange box from the previous slide, if you like. And more than like in the majority of cases, the argument there is null. I think you can give it something specific if you want to initialize the context, but we normally don't. Note as well that I'm exporting this context construct. That's going to be significant. Other than that, this is just an ordinary component. Now, how do I link the context with the provider? And this is how we do it here. I don't like this part of it, but this is what we have to live with. So it's JSX, but the effect of this here is twofold. Number one, it's linking the context with the provider component, because this here, right, is a reference to this up here. And we have a corresponding closing tag down here. Now, let's treat this as a component, and essentially kind of is. So a context is a special type of component, and components can have props associated with them. When it's a context, when it's a component like this, there's a specific prop called the values prop, and what you assign to the values prop, that determines what you are putting into the context to make available to the rest of the components. So this bit here is determining what is actually being placed inside in the context. And they're going to be key value pairs. The keys can be anything you want them to be. The values can be anything you want them to be. More than likely, the values will relate to maybe the state data that's being managed up here. In fact, it almost definitely will be, but it could be any value. The value could be a function that you've declared somewhere inside here. Either way, this is how we populate the context, if you like. And this is how we link the context with the provider component. The third thing to note is, note here that I'm actually using composition. I'm expecting to compose this component with other components. We've seen this props.children before. So that's the expectation. To finish that part, how do we compose it, or where typically do we compose the provider component with the rest of the app? We tend to do that buried within our routing configuration. So here you can see I'm referring to the provider component. This is this guy here. And you'd have your typical routing configuration going on inside here. And so by virtue of the fact that I am composing my provider with essentially with the rest of the app, with all of the pages in my app, then that will allow all of the pages and the components within those pages to potentially have access to the context itself. And we'll see how in a second. So that's kind of boilerplate in a way, really. The next part of the jigsaw is from the consumer's point of view, those components lower down in the hierarchy. How do they now eventually get access to the context? And this is where we use a special hook called the use context hook. And we need to pass the use context hook a reference to the context itself. This is something that I'm importing, you can see here. And what am I actually importing? Well, if I go back 2 slides, I'm not importing the provider. I am not importing the provider component. What I'm importing is this guy up here. So kind of
is the context an object?
You can think of it as an object. In fact, yes, it is. Yes, it is, yeah. The object it actually is, which is a good question as it turns out, the object that it is this object here. Because this is essentially the content of the context.
Yep, thanks.
Yeah. So whatever this returns back to me, context here, inside in this component, I can do context dot, what am I saying here? Access context values with context dot key. So context dot key here would be whatever keys you have defined here. And so we now inside our consumer, we have access to be it a value, which is part of probably the state up here, or it could be a function which has been defined somewhere inside here. So there are the different parts of the jigsaw, and really, like anything, it's not until you put it into use that hopefully it will all make sense. In real life applications, you know, you might actually have more than one context and consequently more than one context provider, because there could be different aspects to your global data. And rather than just banging all of your global data into one context, it would be a better design if you broke up your global data into logical units or parts, and then have a separate context and context provider for each part. But other than that, it just works always the same as before. So potentially, like when you start composing your context providers with the rest of the app, you could have something like this. This is part of my routing configuration now. So it looks like I've got two contexts because it just makes sense. It made sense in the context of this particular application to break up my global data, because there was quite a lot of it. Break it up into, in this case, two logical, coherent and separate units. Now, there are cases, and I'm only including this really for completeness. It's not something that I don't think will arise in terms of your assignment, making a decision as to whether I should or should not use a context, but there are situations where you should probably not use a context. One is if you're only avoiding what I'm calling shallow prop drilling here. Shallow prop drilling would be where you're just avoiding the need to pass props down maybe one level or two levels. Then just actually stick with having prop drilling rather than using a context to avoid it. It turns out now that contexts can be quite heavy from a performance point of view. They can affect the performance of your app if you overuse them. So if you only have shallow prop drilling, then that type of prop drilling is considered acceptable. Now, to be honest, in the lab, we use a context provider, and it could be argued that we're only avoiding shallow prop drilling in the lab, but I did want to give you one example of using the context. So I'm just stating this is a possibility in a production environment. Number two, contexts tend to, from a data point of view, they tend to house stateful data. And the stateful data, again, it's still associated with a component, but as well as associating it with a component, we're putting it into a context construct. Now, if the stateful data should really just be managed by one component and it's not being shared, then don't fall into the trap of just banging it into the context because it's a useful place to put all of my stateful data. Again, that won't arise in your case. But the third one is if the objects, if the data that you're putting into the context are very large objects, then it's argued that they could potentially impact on the performance of your application. Now, having mentioned all three of those, you needn't worry about them from your app's point of view. I will not be looking to see, are you misusing context in your submission?
Diarmuid?
Yes.
How exactly do we monitor performance?
We haven't looked at it at all, but it's something you'd open up your developer tools. The React has very good developer tool plugins, which allow you to monitor.
I see response times and stuff like that.
More concerned with unnecessary re-rendering of components. That's one of the big things, because you could have a React app that might have 100 components in it. Now, if you've got a stateful component at the very top and it changes state, then every single one of those is going to go through a re-rendering. Clearly, but many of them may not need to go through a re-rendering. But it's up to you, the developer, to express in your code which ones do and do not need to re-render. We haven't looked at that at all. So when I talk about performance here, what it relates to is unnecessary re-rendering of components. And that is something we would have to monitor using tools. So, but I haven't looked at it, and it's not an issue I'm concerned with.
No bother, thank you.
Mm-hmm. So that's the provider pattern, and you will see it in the lab accompanying this set of slides. So that's that closed. The next topic is data fetching and caching. So before we talk about what caching is, I need to just define some terms. So I'm talking about a single page app's state or a single page app's data. And all of the data associated with any single page app can be broken up into two parts: client state and server state. Client state is often referred to as app state. Client state would relate to anything that is unique to a particular instance of a client. So for example, if an app had a drop-down menu and the user selected one of the options and that caused the app to change what it displays, then the current menu selection would be an example of client state data. I'll skip over this one for a second. If there is a particular text form somewhere in the app and the user is entering text into the form, that data would be constitute client state. If there's a user log that has to log into the app, then each instance of the app will have its own logged in user data, but that will be private to each instance of the client. The UI theme there, maybe your React app allows the user, once they log in, to change the look and feel of the app, maybe the dark background versus light background. But again, what they set the theme to would be local to a particular instance of a client. So if you had 100 people using your app, then each one of those would have their own specific data related to these aspects of the app, because they're unique to each client instance. That's client state data. And some characteristics of client state data is the following, right? It's owned by the client and it's not shared at all. Okay, it doesn't share with any backend, or it doesn't share with other clients. It's not persisted anywhere. So once you shut down the browser and bring it back up again, you've lost it, assuming now that we're not going to be using local storage or anything like that. So, and you kind of lose the data from one session to another. It's always up to date because really it is just local to the client anyway. Also, I'm saying it's accessed synchronously, because it is local to the data is local to the React app within the browser. So there's no delay in accessing the data. We tend to use the useState hook to create this type of data. We've seen that. In terms of managing the data, I'm saying typically it's managed by a particular component or set of components. So a particular part of the client state might be implemented using the useState hook, and it's managed by a particular component. And we've seen all of that. So there's nothing new there. The global data that I've just been talking about there, that would come under the heading of client state as well. Because we saw that the provider component was responsible for managing the global data. So there's always a component, whether it be in relation to a context or just state data that's local to a client. Either way, it's kind of managed locally by a component within your component hierarchy. That's fine. That's client state. The other type of data is server state. And I'm saying here that this is actually relates back to this M part of MVC. And the very first lecture I gave you, I said React does not care about M. It only cares about V. But there is always an M part to your app that's running in your browser. So something has to manage the server state data. And that's where we're going with this. So first of all, what is server state data? Well, It's the data essentially that you pull from your web API. So a list of movies, the details about a particular movie, my list of friends, all that would constitute server state. And we do have to store this in the browser, okay? But where it comes from is important. It's coming from the back end. Characteristics of it, I'm saying it is persisted remotely, okay? It's persisted in the database behind your web API. It's shared. Every client is going to be accessing the same server state data because they're all talking to the web API, so it is being shared. The accessing of that data is asynchronous, of course, because it has to go across the network. And that can impact on the user's experience. Okay, if there's any kind of network delay, then we get our consequence from the user's experience point of view. I'm also saying it can change. Yeah, it can change without the client. So I might have an instance of a React app loaded in my browser, and somebody else has the same app loaded within their browser, and that other user triggers a change to some part of the web API's backend data. Now, my client, though, won't know about that. So potentially my client could be looking at out-of-date data. Unless I build some logic into the React app that somehow is informed that the data has been changed back at the web API side. And we use state and use effect to implement server state data. So that's that. The next thing, so it's server state data that I'm really interested in here. So I'm saying server state data is, some more characteristics, sorry. How do we manage server state data? How do we manage it within our React app now? How do we manage it from the browser side? One approach would be to use a component to manage it, which is really what we've been using up to now. And there may be different aspects to server state data. So maybe different components may be responsible for managing particular aspects of your server state data within the React app. And what would be nice about that approach is we've got good separation of concerns. We've split out, rather than putting the server state data into associating it with one component at the very top of the hierarchy, maybe into a context and all that kind of stuff. That's from a design point of view, that's probably not great. It would be better if we could somehow separate it out into multiple components or across multiple components, because maybe only one component may need to know about a certain part of the server state data. Obviously, if there are more than one component, then we're back to the context probably a solution, but ideally we'd aim for this kind of approach. And what's nice about this approach is, as I said, better separation of concerns. The downside of it, though, is every time, so if I've got a particular component that is responsible for managing one part of server state data, every single time that component remounts, it's going to refetch the data from the backend, even though, let's say, that data very rarely changes, maybe once a month, once a day even. If I'm moving around my React app inside my browser, every single time that this particular component that's managing a particular part of server state remounts, it's actually going to refetch the data, and that's a big no-no, obviously, because it's doing it unnecessarily. So the alternative, the way to avoid this, is to go down the global data context. Shove all of your server state data into a global context. And then you won't get any unnecessary refetching. But the downside is, okay, there's two downsides really. You're fetching all of the data when the app loads up initially, even though you may not need all of it. Also, you just get poor separation of concerns. Maybe there's only one component that needs to know about a particular part of server state data, but because you've put it into a global context, everybody can now see it, and it's just poor design. In the middle one here, I'm saying you're fetching data. I've already mentioned that. So there's pluses and minuses with option 1 or 2. The best thing is if we could have the best of option 1. The best of option 1 would be this, and the best of option 2 would be this. Can we achieve that? And the answer is yes, we can. There's a third-party library to do it for us. But before I talk about that third-party library specifically, the third, rather than you actually coding all of this state management stuff, there are third-party libraries, one in particular called Redux, which does a lot of it for you. And that has been very popular for a number of years. I am going to be looking at a different third-party library, which approaches the problem from a very different perspective. Really, Redux is nothing more than a glorified implementation of option 2 here. So we know what the weaknesses of option 2 are. Okay, to illustrate all of what I'm trying to get at here now. So I've got this simple little app with 2 pages in it. This is the home page, so it's a variation on my filter friends, and this app is using TMDB. So this is the home page, and I'm getting 20 movies from TMDB. And if I click on a movie, it brings me to the movie details page. Now, because I'm only interested in this discussion here on managing state data, I'm not interested in the UI. So all I'm doing with the movie details that I'm getting from TMDB is I'm just displaying the object that's being returned itself. So I don't care about the UI side of this. Clearly, when I'm saying down here, when both of these pages mount, there's going to be a HTTP request made back to TMDB. Every time this page mounts, I'm going to be requesting the same 20 movies. Every time this page mounts for the same movie, I'm going to be making the same request back to TMDB for that movie's details. And clearly that has not changed, between invocations. And even multiple invocations of this page or multiple mountings of this page during a particular user session, the data isn't changing, but we're still making the API calls, the HTTP calls unnecessary, and that is slowing down the rendering of both of these pages. Now, what I'm showing you here is kind of proof of that. This is a screenshot, and I'm opening up the developer tools. And maybe what I can do at this stage now is, so this app comes as an archive with this week's lecture. So it's behind this here. Where did I put it? There it is. Okay, here we go. Back to the home page. Now, what I want to do though is open up my developer tools and select the network tab. I was playing with this earlier on, but so you need to find the network tab. It may not be in one of the list here, so you just, I don't know how familiar you are with the dev tools, but you'll find it in this list here. So here's my network tab, and what this tab is used for is monitoring any kind of network communication that's happening between whatever is currently loaded into your browser and the web. So I'll go back to, I do a refresh of this, just to send it back to 0. And I'm only interested in right. Now, what I'm seeing here is this is actually the HTTP request that was made by my app to TMDB to get 20 movies. Okay, that's confirmation. If you kind of drill down into that, it'll show you the full HTTP request itself, the headers and all of that. Okay, now, so you need to watch what's happening here. If I go to the very first movie, then my app makes a request for that movie's details. So far, so good. Here comes the problem though. If I now go back to the home page, It's requesting the data all over again from TMDB. And if I click on the same first movie, it's requesting that again. So after the first two, the remaining HTTP requests are unnecessary, but they're still being made. And my app is still waiting for the data to come back before it actually renders the page. We don't see the evidence of it here, but in a much more complex app, it would impact on the latency and the user experience. So how can we get these unnecessary requests from happening? How can we stop them from happening? This is what I'm showing in the screenshot here, really. Okay, all the HTTP requests that were being made as a result of me flicking back and forth between the home page and, let's say, the same movie details page. And you can play with that yourselves. So this is clearly, this is a problem, right? What's the solution to it? Oh yeah, that's okay. The solution is to implement something called caching. And I'm saying caching is where the API data is stored locally in the browser. Well, that would seem an obvious solution, but the caching is a bit more sophisticated than just local storage, you know, the browser's local storage. And what caching will do is it will help reduce the workload on the back end, i.e., don't make unnecessary requests on the back end. Here's my kind of visualization of how caching is going to work. So in my browser, I have my single page React app loaded, and I also have some caching software running in the browser. The caching software will be downloaded with the React app. Okay, so both of these are in the browser. Here's my backend. And so my React app is going to ask the cache, get the first 20 movies from TMDB, or it essentially is kind of asking the cache for 20 movies from TMDB. And what the cache will do is it will check to see, well, do I already have the 20 movies from TMDB? If it doesn't, then it sends the request on to the backend. The response comes back, it stores the 20 movies here, and it returns them back to your React app, and it renders them. If I subsequently ask the cache at a later stage for, give me the first 20 movies from TMDB, the cache will check, do I have them? And it now does. So it doesn't make any request back to TMDB. It just returns the data back to the app. So voila, I have, what it's doing here is the cache is essentially intercepting the requests and checking to see, does it have the data already? And that's really all caching is. It's a local, high performance, low latency storage mechanism for data. You could also have caching going on between your web API and a database, by the way. So caching is not just specific to, you know, single page app running in browsers. Caching is used all over the internet, essentially. So some general aspects or some general terms related to caching, because as I've just said there, it's not specific to single page apps running in browsers. So what is a cache? I'm saying a cache is an in-memory data store. It is a kind of a very simple database. And if it is in memory, then consequently it's high performance and low latency. The structure of a cache is just simply a set of key value pairs. Keys obviously have to be unique. The values can be anything. They could be a primitive, they could be an array, they could be an object. Essentially, the value can be anything that's serializable. So in the case of our demo app there, the values would be either an array of 20 movies or the details about a particular movie. In terms of keys, the obvious key for the cache entry that contains the details about a particular movie might be the movie ID. The key for the entry that contains the 20 movies, I suppose we could call it anything. We could call it Discover, maybe, because Discover, if you remember, is the web API endpoint that provides that data. But you can give it anything you want to. Top 20, call it whatever you want to, as long as it's unique. So our cache is a data store of key value pairs. We have this term too called cache hit and cache miss. So if I go back to the previous, when my React app asks the cache here for some data and it realizes it doesn't have it, so it asks the backend for it, we refer to this here as a cache miss, as in, it just doesn't have the data. The cache wasn't able to help. Whereas down here, we had a very different sequence. This request to the cache would be referred to as a cache hit because what was being requested had a match in the data store. So cache miss up here, cache hit down here. And obviously what you're trying to achieve is maximize the number of cache hits in your cache interaction. Caches have a simple interface. Really, there are only three things that you might want to do with a cache. A, you might want to ask it to, does it have a particular entry? So there's some sort of a get operation and where you give it the key and it looks to see, does it have that? And if it does, then it returns back the data associated with that key. Or you might want to delete a particular entry in the cache because for whatever reason, you know that the entry in the cache is actually out of date, or as we say, it's stale data. Number three, you might actually want to completely wipe the cache for similar types of reasons. The data is out of date. We don't necessarily directly put data into the cache. The putting of data into the cache is managed by the cache itself. From the client's point of view, these are the only possible things that you might want to do. By the client now, we mean this guy over here, obviously. Now, over time, if I've got a React app in my browser and I've been playing with it for a couple of hours and I'm doing a lot of interaction, then the data the cache is potentially containing a lot of data in it. It's filling up. And maybe some of that data is no longer being requested by my React app. So it's suggested that the entries in your cache should have an associated time to live attribute connected with the entries. And I'm sure you kind of heard of time to live before. The purpose of the time to live is once an entry in the cache, once its time to live expires, then the cache itself will remove the entry from the data store because it hasn't been requested for quite a while by the client. So why hold on to it? Because you don't want your cache growing too big within the browser. Now enter a third-party library called React Query, and this library implements caching for React apps. And it's actually very easy to use, arguably, I suppose. But so what this library provides us with is a set of hooks. Okay, so it's very up to date in that sense. The earlier incarnations of it, the interface was a little less user-friendly or developer-friendly. So it provides a set of hooks, and it's these hooks. This is how we, as React developers, interact with the cache. And in particular, really all we're mainly interested in doing is asking the cache for particular data, if it has it. And if it doesn't, letting the cache get that data and return it back to us eventually. So the most used hook is a hook called the use query hook. And this hook takes two arguments. The first is the key that you are interested in. You're essentially asking the React Query library, do you have an entry in your cache with this as its key? And if it does, then it's going to return all of this to us, which I'll talk about in a second. But if it doesn't, how does the cache know how to retrieve that data? And that's what the purpose of the second argument is. This is going to be a function which we as the React developer must write. And this function contains the code to make the TMDB call. Essentially, we've seen this kind of stuff before. So this might be a function that contains a fetch request to TMDB, which we've seen. Right? So you do have to tell this React query library, you do have to tell it how it talks to the backend, because obviously it doesn't know what backend it's talking to. Now, either way, what it returns back to us is this large object, and I'm just doing destructuring here. And I'm explaining here the different parts of the object that's returned back. So clearly the first part is going to be, this is going to refer to the data associated with this key, whether that be because it found it in the cache or it eventually got it from the backend, put it into the cache, and then gave it back to us. This here is going to contain error information, just in case there was any problem talking to the backend. This is a Boolean, which we can use to determine whether we're still waiting for the response to come back from TMDB or from the backend, because we're not going to be able to avoid that problem. Then, the network callers are going to have to be made, but maybe we want our React component to display some placeholder information while we're waiting for the data to come back. And the way we find out whether we're still waiting or not is by checking this Boolean. And this is also a Boolean, which just either is true or false, depending on whether the React query caching was able to communicate properly with the backend or not. So all of this is available to our React code to do whatever it wants with it. Clearly, this is the most important one. And I'm saying down here that one of the consequences now of us actually introducing this into our Movies app is we actually won't need to use the use effect and use state hook anymore, or not as much as before. So we'll actually be removing quite a lot of code and replacing it almost with a one-liner like this. So it's a really, really nice library. And if I know I'm running out of time now, but I'll just make one change to, and I'll show you. You can play with this little app yourselves. But if we look at the home page for this guy, so here's the home page, and it has all the stuff that we'd expect, our use state, or the movies, and the use effect. So what you need to do in order to convert this into an app that's using the caching, I explained that in the README. And you can read down through it, but essentially we need to take this code here. Where does it go? Sorry, no, this code here. And stick it into my home page. And get rid of this. Save that. And now I'll just illustrate one thing to see the effect of this, and then I'll leave it at that. So let's start from scratch again. Let's go back to my home page. And I'll just do a manual refresh. Okay, so it's made the API call. It had to, because the cache had nothing in it. I'll go to one of my detailed pages. And if I go back to the home page, okay, if I go back to the home page, suddenly there's no extra HTTP call made to TMDB, because it already has the data from this HTTP request here. And every time I go back to my home page, it's not going to make the unnecessary call. It is still going to make the unnecessary call for the detailed page, because I haven't implemented caching on that yet. So when I click on this here, you know, it's made the request again. But if I go back to the home page, no. Now, so that's caching. There's a little bit more to it that I need to discuss with you. And I guess we'll have to leave that until the Monday lecture. So I'm not sure if you're still there or not, but
I'm here.
Yeah, okay. Did you want to ask me something or?
No, no, it seems very straight. I was wondering what would happen once you had the cache in, but that explains it, yeah.
Yeah, and we can actually, there's really nice developer tools that comes with the cache, so we can actually look inside, see what is in the cache and play around with it. So we'll leave that until the next lecture.